Okay, everyone. Welcome to another Contino live session. So first of all, just a bit of housekeeping and a reminder that this session is being recorded and will be available later on. Today, I'm going to talk about, as the title slide says, how to secure serverless applications using the principle of least privilege. So the way it's structured is that it will be about 45 or 50 minutes of kind of me talking and presenting on the topic, and then there'll be sort of 10 or 15 minutes for questions at the end. So first of all, for those who are not familiar with Contino, Contino are a digital transformation consultancy, and we generally work with enterprise clients. We help those clients to accelerate their cloud adoption and maturity, and help them to upskill so that they can focus on managing the platform themselves in the future. So that's a bit about who Contino are, and I work as a principal consultant at Contino, and have worked there for a bit over a year and a half now. Across a range of different clients. So a bit of background to this talk. So the talk will be mostly AWS focused, although the concepts you can take away will be really applicable to Azure and GCP and are really kind of quite cloud agnostic. So a bit of background to me. I've worked with serverless applications prior to my time at Contino, and for various different clients during my time at Contino, and using different architectures and different services within AWS. And I think serverless is a really interesting concept, and it allows you to kind of build very scalable applications while simultaneously reducing your costs, decreasing your overheads, like in terms of your management overhead. And also a hot topic at the moment is sustainability, and serverless applications allow you to build more sustainable solutions, greener solutions, because if you're only using certain resources in the cloud, when they're needed to be used and not having them sort of switched on all the time, that's going to have less of a carbon footprint. I also wrote my my master's dissertation earlier this year on the topic of this webinar, and so I did a lot of research into the topic as well, and that's kind of a little avatar representation of me on the right hand side, and as you can see, I do always wear the same clothes. One of the perks of working for Contino is that you get a lot of free clothes, so you don't have to do too much clothes shopping, which I like, but my wife doesn't so much. Cool. So I guess the starting point of this is understanding what the principle of least privilege is, and I think most people who kind of work in technology have a decent idea, but this is kind of baseline setting, and I've got a couple of definitions here. One of them is from the US National Institute of Standards and Technology, otherwise known as NIST, and the other one is from AWS themselves. I'm not going to read them out for you, but in my view, kind of the key takeaway from this is that entities, and whether those entities are people or applications, should only have the permissions and the access that they require to carry out their function. So in the same way that when you work in an office, you wouldn't have the username and password credentials to everyone's laptop in the office. You would only have those credentials to your laptop, because you don't need to access other people's laptops to do the work, so you shouldn't have access. That's least privilege. And this is kind of all very well, but what do cloud providers say about how you can use and implement least privilege when working on their platforms? So as part of the master's dissertation that I worked on earlier, I I reviewed a lot of literature from AWS, from GCP, from Azure, and from kind of well-known security organizations. And I've just taken a few here in terms of what they say about best practice. And again, I'm not going to read the quotes, but as you can see, I think we can all agree from these that all of the cloud providers mentioned recommend adhering to least privilege. In particular, AWS, but all of the cloud providers essentially say the same thing. The thing that I found was that saying you should adhere to least privilege is one thing, but guidance can be lacking on the best way to achieve that. Another thing I found was that specific guidelines on least privilege tended to focus more on the people using the cloud rather than applications that are running on the cloud. And the guidance can be somewhat vague. I think the bottom quote that I've got there really sums it up. Check that your code always runs with least privileges required to perform its task. That's all very well, but it doesn't really help you to implement least privilege at all. So that's kind of why I think it's worth doing a bit more of a deep dive into this subject and looking at how you can actually better achieve least privilege. And first, before we get into that, why would you want to achieve least privilege? So what are the benefits of that? So first of all, for me, a system that implements least privilege well is simply harder to attack. It's harder to compromise, it's harder to cause damage to. If you've got a resource in the cloud that allows lots of access to it, then it's much easier to misuse that resource to carry out an attack. Secondly is the blast radius is reduced. So if there is a successful attack, the amount of damage that attack can do is reduced. So in a serverless application or a serverless system, you typically have many different resources that are part of that application, part of that system. And if those components or if those resources have very open permissions that allow a lot of access to them, they typically need to communicate with one another. And so it allows you an entry point into that system or that application. And so compromising or misusing one of those resources potentially gives you an entry route to be able to misuse other resources, for example, a database or something like that. The third point here, and it's generally big news these days when customer data confidentiality is broken. Achieving least privilege to a good extent can help to reduce the risk of financial or reputational damage for an enterprise. So when you hear in the news that X, Y, and Z company had a data breach and lost a lot of their customers' data, what typically happens is a couple of things. Typically, first of all, they'll get a fine, so that hurts the company financially. But possibly even more important for the company, it kind of leads to a loss of trust between the company and their customers. So that their customers and even potential customers may not trust that company to hold their data, and they may switch to a competitor, and the company will suffer that way. So if as an organization, you can show that you protect your customers' data well, you'll build that trust, and you will gain more customers. And finally, I think this is kind of an engineering kind of focused one, is I think if you set out your stall and say, we would like to adhere to least privilege as much as possible, you're kind of giving a clear standard to the people who build your applications. There's no confusion over over what the kind of standards that you need to develop are. And it allows developers and engineers to focus on the functional task at hand, rather than having kind of unclear requirements and then having several meetings to discuss those requirements, which delays the building of the actual application. So I now want to talk a little bit about why I think least privilege is hard to achieve, and why I think it's even harder in serverless applications than it is in your kind of more traditional server-based applications. I think the first thing to call out is that you can never hope to achieve kind of 100% least privilege. So you can never hope to define all of the conditions under which access should be granted. It's quite difficult to actually measure how to what extent you're achieving least privilege. So what's the metric by which you measure that, and how do you decide what is good enough? So both of those things make it difficult to determine the level of effort that you should put in. And since you can't achieve 100% perfection in least privilege, these become very difficult questions. And actually, you can try to go too far, and the effort may actually outweigh the benefits once you reach a certain level. If you keep trying to lock things down for tiny edge cases and things like that. So that's one thing that makes it difficult. It's not kind of cut and dry. The second thing, and this is very important, I think, is that serverless applications generally are made up of many different small components. So if you're talking the AWS world, you're talking about APIs, you're talking about Lambda functions, and lots of different things. So you're essentially taking, if you take a server-based application that may be just something running on a VM or an EC2 instance in the AWS world, you might break that down into lots of different Lambda functions, which then need to communicate with one another. There's data stores you've got to think about. There's APIs you've got to think about, and we'll see a bit more of this later. But everything's a lot more decomposed. The third point, I think, speaks for itself. Developing applications with bad security is much easier than developing applications with good security. If you don't have to worry about things like encryption and permissions and what needs to access what thing, it becomes very easy. But obviously, you know, that's bad practice. So we don't want to do that. But I think, in my experience, when developers have time constraints, they start to cut corners, and this may be one of the areas where they cut corners. And the last point here is that another thing I've seen in various places as well, that non-functional requirements, like least privilege as part of security, typically get less attention than the actual functional requirements of tickets that developers and engineers are working on. So when you're working on a ticket, you essentially, as a developer or an engineer, you typically focus more on what the functionality is that I need to build as part of that ticket, rather than does this thing need to be encrypted, or things like availability or performance, all of those kinds of things. I'm not saying it happens everywhere, but I've seen it happen in lots of different places. So as I referred to kind of in the last slide, serverless applications are typically broken down into lots of different components. And each of those components needs a permission set. So I've kind of tried to define here what I think a typical serverless application might look like. And this is again AWS based because that's my kind of area of expertise. But this kind of thing would look very similar in other clouds as well. So essentially, you've got an API, which is your access point into the application. You've got a number of different Lambda functions there that contain your application code. You've got a SQL database in the form of RDS, which stores your relational data, and then you've got these Lambda functions that interact with this. You've got a queue system, which is SQS here, which allows kind of decoupling between different parts of your application. And you've got a NoSQL database in the form of DynamoDB, which stores your non-relational data. Additionally, you've got encryption keys, which in AWS is KMS, which allows you to encrypt the data inside these databases and inside this message queue. You've also got logs going out to CloudWatch, and this is really kind of a simplified diagram because you might have other things like object storage in S3. You might be using Secrets Manager to store database credentials that these Lambda functions can obtain at runtime to access this, and several other things. But the point is really that all of these things, or at least most of these things, need permissions sets. So this takes the form of IAM policies. So you've got your API, which needs a resource policy. All of your Lambda functions need to have an attached IAM role, which defines what they're allowed to do. There's also a resource policy that you can define on the Lambda functions, which defines which things have access to those Lambda functions and what access they have. You've got networking rules in here. RDS requires that you use a security group, which is essentially just a firewall which defines networking rules to allow access to it. In your message queue, you've got an access policy which defines what other components in the cloud have access to that queue and what access they have. And you've got all of these KMS encryption keys as well that need to have a key policy attached to define the various permissions on them. So already you can see with even this very simple architecture, you've got quite a lot of complication in there in terms of the number of policies and permission sets that you need. And also the number of permissions you need. So if we just take one service, for example, so if we take DynamoDB, and imagine you're a developer and you're writing a policy for your Lambda function that needs to access DynamoDB, and you need to adhere to least privilege. So you need to give it the exact permissions that it needs to do only the things that it needs and nothing else. Well, there's 58 different permissions in DynamoDB, and some of these permissions apply to different resource types. So the DynamoDB service is made up of tables and streams and backups and various other things. You've also got the concept of condition keys that allow you to grant access, but only under certain conditions. And you've got different keys. You've got different permissions, that support different condition keys. So you can use some condition keys with some permissions, but not others. So unless you're kind of a DynamoDB domain expert, it becomes very difficult to know, okay, do I need to give my Lambda function the batch get item permission or not, or do I just need to give it the get item permission? Which of these does it really need and which doesn't it need? So as you can see, it becomes quite difficult. And I've got some examples, a concrete example of what a bad policy looks like, what a slightly better policy looks like, and what a good policy looks like. So apologies to those of you who are not familiar with IAM policies in AWS. But this essentially is just a JSON object, and it defines a permission. So it's got an array of statements. Each statement has an effect, which can be either allow or deny. It's got another array of actions. So this is the actions or the permissions that whatever this policy is attached to is allowed to perform. And then it's also got a resource. So which for these actions, which resources can I perform that action on? So, and this character, this star character, is just a wildcard, which means anything. So as you can probably already tell, this is quite bad, because we're essentially saying whatever this policy is attached to has permissions to perform all DynamoDB actions on any resource. So that means writing to tables, creating tables, getting data from tables, and it applies to all tables. So if you imagine you've got a Lambda function that becomes compromised, that's potentially a lot of data that you're exposing there. You could improve this a bit by saying, okay, I only want this to perform the get item action, so that I'm no longer allowing anything to create table, whatever have this policy is attached to create tables or to write data or to update data. It's purely just for reading data. But it still applies to all resources. So you're still giving access to all the data in all of your DynamoDB tables, essentially. So again, you can improve that by locking this down to a separate, to a specific rather table. So now you're saying, and this is where I think it gets to the good end of the spectrum. You're saying, okay, you can only read data from this specific DynamoDB table. So in that case, if this is a Lambda function that has this permission, if that Lambda function becomes compromised, then the only data that's exposed is the data that's in this specific Dynamo table. I said before that you can't achieve perfection in least privilege. So this is good for me and would work for most circumstances. I talked about condition keys earlier, but you could lock this down further using condition keys. But I think in most circumstances, you probably wouldn't need to go that far. This would kind of be good enough for you. But for specific use cases, you might want to do that. Cool. So we're gonna move on in a little while to talking about specific risks of not achieving least privilege. What happens when you don't achieve least privilege? But I think before we do that, it's important to identify what our general concerns are when we're talking about security. And we generally talk about three main things when we're talking about security and security properties. I've said security properties of data here because, in my opinion, when you discuss security, you're generally talking about data. You don't really care about EC2 instances or Lambda functions themselves. What you really care about is the data that's either stored on the EC2 instances or the data that they have access to. So if you have a problem with your VM, with your EC2 instance, then you can quickly and easily spin up another one. But if your data is leaked, then it's out there forever. So there are three main properties of data that we're generally concerned with, and the first is confidentiality. So confidentiality means that the data is only accessible, only able to be accessed by authorized entities. And this is the one that most people think about when they think about data. So people don't want unauthorized people to have access to their data. And if that happens, then it's known as a disclosure. So if you break confidentiality, the data's been disclosed in an unauthorized way. The next one is integrity. So integrity states that the data can't be changed by unauthorized entities. And this kind of gets talked about a bit less, but it's potentially even more serious in circumstances if people can go into your database and just start changing data. There's a lot of harm that they could do with that. And breaching integrity is known as unauthorized alteration. And finally, availability. So availability means that data can be accessed when and where it's needed. And in modern applications, this is really important in terms of data, because modern applications are really data driven. So they rely on data. An example of an attack on availability would be a denial of service attack, whereby an attacker overwhelms your application and stops it from running because it simply can't service the number of requests that are being made to it. In the serverless world, this kind of attack is more known as a denial of wallet attack, because serverless applications are so scalable that they can still service the number of requests, but at the end of the month or whenever your billing period is, you'll get a huge bill because you've essentially been using a lot of resources. And a breach of availability is generally known as destruction. So how do these properties then relate to risks? Well, firstly, a risk generally relates to a breach of one or more of these security properties, so confidentiality, integrity, and availability. So I've got an example here, and this is a specific one that I identified as a particularly high risk when I was writing my master's dissertation. And in this case, the security property we'd really be talking about would be confidentiality. So the risk is that someone gets access, someone uses a misconfiguration to get access to a cloud resource, and that gives them access to data. So it exposes data. And potentially there's an attack on integrity here as well, if they can also change that data. So I think to understand a bit more about this, we need to identify what we're talking about here in terms of vulnerabilities and threats. So a vulnerability is a weakness in a system that can be exploited to cause damage to an asset. So when we say damage, again, I'm referring back to the things in the last slide: confidentiality, integrity, and availability. And an asset, generally, we're talking again about data. And a vulnerability, yeah, as I say, a vulnerability attacks an asset, and it has a certain impact. So if that vulnerability is used to conduct an attack, there's a certain impact. A threat generally has an attacker. So in this case, we've said the cyber criminal is our attacker, but this could be equally you know, an organization, you know, a nation state in some cases. They have a certain capability, they have a certain aversion to risk, and they have a certain frequency in which they'll conduct this attack. And these two things, the vulnerability and the threat, as you can see in the detail here, they kind of combine to form the overall risk. And there's a procedure for doing this in terms of identifying vulnerabilities, of identifying threats, and seeing which threats can use which vulnerabilities to then cause a risk, and evaluating those risks to give you kind of a risk level. So I mean, similar examples to this could be made for different types of attackers, as I mentioned already, targeting slightly different assets. But when we're talking about least privilege, what I found is the vulnerability is generally related to a misconfiguration of an IAM policy or a networking rule. And that allows the attacker an entry point into the application, and from there they can conduct attacks. And these are really just the types of attacks that they can make. So these are the overall risks, sorry, that can be realized. So that they really relate to data loss, so a loss of confidentiality, data corruption, which is a loss of data integrity, and a loss of service or a loss of funds, which is an attack on availability. And kind of what I found was that the vulnerability, the weakness in almost every risk that I identified when I was conducting the dissertation project was again related to either an IAM policy or a networking rule misconfiguration. So that's kind of the key, really. The threats again can be a bit more varied, but inevitably involve some kind of attacker trying to steal or corrupt data, or to conduct a denial of service, denial of wallet type attack. So kind of once you have a good idea of the security risk you're facing, you can start to look, I think, at the controls that you can put in place to mitigate them. So after thinking about this, and after conducting interviews with other people from Contino, kind of some of the items on the list of security controls that I think could be put in place to help better achieve least privilege are listed out here, and I'll deep dive a bit more into some of them after this. The first one is in the AWS world, IAM Access Analyzer, and this is one of the things I'll go into a bit more detail, but very briefly, it contains a number of different features that can help you prevent bad security practices, and also help you to identify possible vulnerabilities, both in your existing application and prior to implementing changes. Excuse me. And the next two things, so shift left on security and DevSecOps, are more cultural things, but in my view are very much intertwined. So a shift left approach to security means giving consideration to security earlier in the development lifecycle, and DevSecOps really advocates for continuous security testing, and those two things combine to deliver a state really where security is built into requirements. So you're shifting your requirements left into the original requirements, so that they're embedded in the tickets that are going to be worked by the engineers and the team. And that security is measured and evaluated in the form of DevSecOps whenever changes to the application are made. So this kind of gives you a better security baseline that can be achieved and also maintained going forward. The next thing is static analysis tools. So what do I mean by this? So typically modern cloud infrastructures are built using infrastructure as code. So AWS have their CloudFormation service, which allows you in either JSON or YAML to define what your infrastructure should look like. So the properties of your S3 bucket or your Lambda function or whatever. What has now been built on top of that are static analysis tools such as CFN-NAG and CloudFormation Guard, which essentially scan your static code and look for vulnerabilities and identify vulnerabilities in that code. And I'll give a quick demonstration of one of these a bit later on. But that can be built also into your DevSecOps methodology and executed as part of your continuous integration, continuous deployment pipelines to deliver that functionality when you're making changes, and to identify problems as early as possible. So In my opinion, developers who are developing infrastructure code should all be encouraged to run these tools locally, as it helps you to identify problems at the earliest possible opportunity and fix them at that point, rather than fixing them later down the line, which is going to be a lot more effort for you. I think, as I mentioned earlier as well, that the nature of serverless applications means that they're very decomposed. So they're made up of lots of different components, and that makes observability quite difficult. Where you might have had before a single application running on a VM, you've now got several different Lambda functions. They might have message queues, things like that, going back to the architecture I showed earlier. And it can be quite difficult to see what the interactions are there. But again, there are tools that can help you to do that. In AWS, that's really the CloudWatch suite of tools, and also X-Ray can help you to do things like monitoring, storing your logs and log analysis, and also tracing. So I think that's something that's really important in serverless applications, because that can help you to understand what interactions components in your application actually have, and you can look at which are needed and which are perhaps not needed, and that can help you possibly even to identify attacks as they happen. You know, if you've got two components that don't usually interact, but suddenly they start interacting, then maybe something's going on there. And also reusability for me is a big one. So I think it's taken for granted when you're developing applications. You use things like classes and code libraries, so that you don't have to reinvent the wheel and write all the code that you need up front. And it also helps to embed best practices. So I think earlier on this year, the CloudFormation team at AWS introduced the concept of modules. So modules allow you to create reusable CloudFormation templates that you can embed your best practices in, and then allow everyone in your organization to use those. So you haven't got people developing the same resources, defining the same resources in lots of different places. You've just got one central place where that's defined, and they can be reused. Cool. So, as promised, a bit more of a look at IAM Access Analyzer. So, as I said before, IAM Access Analyzer can do multiple things for you. So, first of all, it can look at your identity and your resource policies, and it can determine what access has been granted to entities outside of a defined zone of trust. So a defined zone of trust can be either a single account, a single AWS account that is, or an organization. And when it runs, it gives you some findings, and each finding tells you about the resource that can be accessed, the entity that is able to access it, and the level of access that that entity has. So this can help you identify and track where the access you've given might be too permissive, and you can go and look at that and decide if it is or if it isn't, and do something about that. And if you've decided that the access that it's identified there is what you've intended, you can archive that finding so that you won't keep going back to the same thing again and again. And you can even do this actually before assigning the permissions. So for things like S3 bucket policies and KMS encryption key policies, you can run the access analyzer before you apply the policy, and get it to tell you what access outside of your defined zone of trust there is to that specific resource. And I'll give an example of one of those findings in the next slide. Another thing that you can use the IAM Access Analyzer to do is to generate policies based on your CloudTrail activity. So CloudTrail, for anyone who doesn't know, keeps a log of all the API calls that have been made inside AWS. So what access, what services have people been accessing, and what specific API calls they've been making. So the access analyzer can look at all of that data and determine, okay, you know, what's the normal state of operation? Because if you've got policies, if you've got permissions, sorry, attached to things that are never being used, then they're probably not needed, and you can get rid of those, because that takes you a step closer to achieving least privilege. And finally, the access analyzer can help you to validate your policies against pre-configured security rules and some best practices as defined by AWS. And again, that's kind of a preventative action that you can do before applying those policies. So it's preventing you from creating vulnerabilities in the first place, which is always what you want to do, rather than trying to fix them later down the line, I think. And this is really just an example of what I was talking about in terms of the findings that are generated for you. So we've just really got a finding ID, which is a unique reference to it. We've got a resource. So this has found that this particular S3 bucket allows access from all principals. So this means it's public, and these principals have the permission level required to perform these actions. So get object and get object version. So what you've essentially got here is an S3 bucket that has public read access. If that's what you've intended for any reason, that's fine. You can archive this. If it's not, and this is not what you intended, you don't want public access to this S3 bucket, then you can go and take action on this and lock this down. So the next thing I want to discuss a bit is CloudFormation modules. So as I mentioned earlier, it's a new feature, or a relatively new feature now, that the CloudFormation team at AWS released earlier this year. And in my opinion, it vastly improves and matures the CloudFormation experience. For me, reusability of code, any type of code, is quite essential for a mature platform. So the modules feature basically allows you to define your resource definitions that conform to your best practices, and upload that to the CloudFormation registry, and then anyone in your organization can access that. So an example of this might be you've got an S3 bucket. S3 buckets are used all over the place, and there are certain security features that you can turn on. You can turn on encryption, you can turn on versioning, you can turn on various other things, but you can also define a policy that would help you to conform to least privilege and make that part of your make that a CloudFormation module, so that you've got those best practices embedded, and then anyone in your organization can then come and consume that and have those best practices built in. It really is a good feature, I think, that allows that reusability. I've also got a blog post that talks about this, so if anyone's interested, I'll happily direct you to that. And then finally, I think static code scanners, I think, again, are a really vital part of helping you to identify potential vulnerabilities before they make it to production, or ideally before they even make it out of your development environment. And then these are quite good at highlighting where your permissions that you're granting are too permissive. And these have really become more and more popular for infrastructure code. I mentioned a couple of tools earlier, CFN-NAG and CloudFormation Guard. You know, they're really easy to install, and very easy as well, and quick to get up and running. So they can really help you very quickly identify and remediate security issues, including those related to least privilege. And I think, as I've stated several times already, the best place to remediate any kind of bug is at the source. So before you've built on top of that, because the longer the problem goes unnoticed, the more will have been built on top of it, and therefore the harder it will be to fix. You've also got the issue of context switch. So the developer who wrote an IAM policy, which may later be found to have a vulnerability in it, might have had a very good reason for doing that at the time, but if they have to come back to it 1 or 2 months down the line, then it's very unlikely that they'll remember what that reason is. So I'm just going to switch over to a very quick demo of actually CFN-NAG in action at the moment. So what I've got here is just an IAM role resource, which has got a policy section, and it's got one policy attached to it. And some of you have probably already spotted the vulnerabilities. And this is a very simple example, but this kind of just demonstrates how CFN-NAG can help you to identify those vulnerabilities. So it's very simple to run. So you install it. You can use brew to install it on a Mac, which I'm using, and then you just simply run CFN-NAG scan and provide it the import path, which is just my YAML file CloudFormation template that I've got here. So if we run that, it very quickly comes back, and I'm not sure if you can see that very clearly on your screen, but it's saying that the IAM role should not allow the star action on its permissions policy. So star action, yes, we've got that here. So then we can go and rectify that very quickly and just define a specific action. So only the get item action instead of all actions. If we save that and run this again, we can see that the fail has gone now, but we've still got a warning. And it's saying that the IAM role should not allow star resource on its permissions policy. So again, yeah, we've got this star. So we're allowing access to all DynamoDB tables. So if we rectify that, and I haven't got an ARN, Amazon resource name of a specific DynamoDB table, but let's just pretend this is an actual DynamoDB table. And then if we run that again, then we've got 0 failures and 0 warnings there. So that we're in a much better position than we were at the start there. But not all developers will run these kinds of scanning tools all the time. They should be encouraged to do so, but you certainly can't guarantee that they're going to do it every time. So I would recommend that these kinds of tools are built into your CI/CD system so that they run on every code change. And not only that, but you should think about failing the build if you're getting security failures like we were just seeing in the example there. And taking that a step further as well, those issues should be surfaced to the team so that they can be rectified very quickly and at source. So just to finish up here, the kind of the key takeaways here are that least privilege is still highly important in serverless applications. Serverless is not a silver bullet that means you don't have to care about security and you don't have to care about the permissions that you're giving. It's still very important. And in fact, it can be even harder to achieve in serverless applications because of the decomposed nature that can increase the complexity if not managed well. But I think on the upside, a combination of tools and cultural practices that I listed earlier can really help to improve your posture and stop the decomposed nature of serverless applications from being a burden and really becoming an enabler. So that is the end of the presentation. Are there any questions? Okay, so I've got one here around which scanning tools would you recommend? I think there's no one particular tool. I mentioned a couple there. If you're using CloudFormation, check out CFN-NAG, check out CloudFormation Guard. Both of those are quite good tools. If you happen to be using Terraform for your infrastructure code, you might choose a different tool. If you're working in a different cloud platform, then you might choose another tool again. But I think it's about finding the right tool for your team, and maybe evaluate a couple of different tools and choose the right one for you and your team to accomplish what you want to do. Cool. And another one of how do you determine the vulnerabilities and threats in your particular system? I think this one has got to be a bit of a collaborative effort. So, sitting down as a team, looking at your architecture diagrams and thinking, starting off from the point of where are the weak points in my system? Where could my system possibly be attacked? Thinking about those vulnerabilities, then thinking about the threats. Who would be the threat actors that particularly want to attack the system? How would they do that? What method would they use to do that? And then building up that picture. Once you've got those weak points and you've got the kind of the threat, you can look at, okay, which of those threats could potentially exploit which of those vulnerabilities, and then if you put those two things together, you've got a risk. If anyone wants a bit more detail about that, then I'm happy to connect on LinkedIn and discuss it with you further. There's kind of a whole methodology about how you then determine the level of the risk, and then how you evaluate how each of your security tools mitigates those risks. Cool. So if there are no more questions, I think we can wrap it up there. Thank you everyone who's joined and listened. I hope you found that useful. If you have, we've got plenty more webinars. If you go to contino.io/events, you should be able to find all of our previous Contino live events, and there'll be some more coming later in the month and later in the year as well. So thanks everyone.